Hi, this is COMP1010 at the University of Manitoba. I'm Dr. Celine Latulip, and today I'm going to introduce you to using while loops. So I've shown this flowchart before, and this is a funny flowchart about providing tech support to your friends and family. What you might remember is that this flowchart illustrates choice. Try to find a menu item that looks related to what you want to do. If you can find one, then great, click it. If you can't find one, then pick one at random and then click it. So this if is depicting the idea of a choice here. And so you know how to do that with if statements. But there's also a loop in this flowchart. So if we click the button and it didn't work, then, and we've been doing this for less than half an hour, then we might want to try another button. Click it. If it didn't work, still haven't been doing it for more than half an hour, try another button, etc. And so there's this idea of repetition, doing things over and over again. And so in programming, there's three major structures. There's sequences, which you've done, which is where processing executes lines of code from top to bottom. And then there's choice, which are the if statements. And then there's repetition, which are loops. And once we add loops, you can program pretty much anything. So the while loop is the most fundamental loop. It's the simplest form of loop that we have. And it looks like this. We have the keyword while, we have round brackets, we have a Boolean expression, something that will be either true or false, and then we have some code statements inside of a block defined by curly braces. In a while loop, we're going to execute code statements over and over as long as the Boolean expression is true. Once the Boolean expression is false, we skip this block and go down to the code that's below. So this is a flowchart that illustrates this idea. We check the expression. If it's true, we execute some statements, and then we come back and we check the expression again. If it's true again, we execute those statements again and come back and test the expression again. If at some point this expression evaluates to false, then we don't execute these statements and we go down and do the statements that are after the loop. So we call the Boolean expression that's in the round brackets a condition. And if the condition is true, then we repeat the commands inside the block. If it's false, we do the commands that are below the block. So here's an example of a simple while loop. First, we initialize an integer variable I to 2, and then we have our while loop, and the condition says I less than 10. So this is a numeric comparison, an integer and another integer. If our integer I is less than 10, then we're going to print it out and we're going to add 1. So remember that plus plus is a notation for incrementing by 1. So when we start, I is going to be 2 and 2 is less than 10. So we're going to print out 2. Then we're going to increment it and I is going to be 3. We're going to come back and we're going to test this condition again. Now I is 3. 3 is less than 10. We print out 3. We increment I, it becomes 4, etc. And so we'll keep on doing this. At some point, I is going to be 9. 9 is less than 10. We print out 9. We add 1. I becomes 10. We come back to the top and we test, is 10 less than 10? And that's false. 10 is not less than 10. 10 is equal to 10. So at that point, this condition evaluates to false. We don't execute these statements. Instead, we skip down and we execute this finished and print that out. So you might want to know, what is the last value of I to be printed? And in this case, the last value of I that will be printed is 9. Once I is 10, we no longer execute these statements. And here's what this looks like when you run it in processing. You can see the numbers counting up, and then after we print out 9, the next thing that happens is we print finished, which is the code that comes after the while loop. So to write a while loop, you type the keyword while, you add a Boolean condition, and that's the condition that defines when the stuff inside the loop should be executed. You put it in round brackets. You add curly braces to create a code block, and you put any code that needs to be executed each time the loop runs inside of those curly braces. You also need to usually add some start or initialization code before the loop to set up the things that are in the condition. And then you typically need something inside the loop, what we might call upkeep code, that will change things so that at some point the condition will be false. Otherwise, we'll have a loop that runs forever. So if we want to count to 1,000, the first thing we're going to do is start our while loop. We'll say while I is less than or equal to 1,000, and we print out the value of I. So this is good. We're going to print out a bunch of numbers, but we need something more. I is undefined, so we need to know what is I. So we're going to initialize I before the loop and set it to 1. So now we're going to come in here. I is 1, that's less than or equal to 1,000. We're going to print 1, and we're going to come back. I is still 1, and we're going to print 1 again, and we're going to come back. So what you see here is that this is good, but we're missing something that causes this condition to change. And so the last thing we need is to add code that says I++, so that each time through the loop I changes, it increments by 1, and at some point I is actually going to be 1,000, and then we'll stop our while loop and do whatever comes below. And here's what that looks like when we run it, and you can see that we are printing out numbers up until we get to 1,000. And we actually do print out 1,000 here because we have while I is less than or equal to 1,000. If the equals was missing here, then we would stop at 999 and we wouldn't print out 1,000. So it's important to note that once you're inside the loop, everything in the loop body gets executed. The condition doesn't get tested again until after we've finished all of those statements inside the loop body. So look at this example. We're printing the values 1 to 9. We initialize I to 1. We have a condition that says while I is less than 10, and we print out I, and then we increment I, and then we have another print statement here. This print statement prints out and after each number. And so it should print out 1 and then we come back in here, I will be 2, 2, and etc. But it's important to note that once we get up to 9, 9 is less than 10, we print 9, we increment I, it becomes 10, we still print and. So we're going to have 8 and 9 and I is going to be 10. We're going to come up here, 10 is not less than 10, and we stop. And so that will then look like this. Here we go. We have 7 and 8 and 9 and. And so you might think that the minute we add one more to I and it becomes 10, we stop right here because now this isn't true anymore. But in fact, we actually continue on. That doesn't get tested until we come back up here. So this line does get executed even after I is incremented to be 10 right here. So there's 4 parts to our while loop. You can think of this as the priming or setup or initialization code. We have our test or our condition, which has to be a Boolean expression. We have the body of the while loop. This is the set of statements inside the curly braces that will be executed as long as this is true. And somewhere in this body, we typically have some upkeep code that changes something so that at some point this condition actually evaluates to false. So here's some examples. This example is with numbers. We want to write a while loop that prints the numbers from 500 down to 400, counting down by 10. And so we have our initialization code, I equals 500. We have our Boolean test, while I is greater than or equal to 400. So this is a Boolean. We've got a number being compared to a number. It will either be true or false. And then we have our body. So we're going to print out whatever the number is. And then we have the upkeep code. And this is changing I so that at some point this condition evaluates to false. And this is what this looks like. It prints out the numbers until we get down to 400 and then it stops. Here's an example using a string variable. So we just talked about string variables. We know that strings are made up of a series of characters, and so we can loop through and do something with every character in a string. And so if we want to loop through and print each character in a string on a separate line, we can do that using a while loop. Here's the code. We have initialization where we set our string to hello. It's called myString. We initialize a variable that's going to count along as we go through the characters. We're going to set it at 0. And this is because we index from 0 in strings. We have a variable called len, which is the length of the string. So when we call myString.length, it's going to return 5 because there's 5 characters in hello. So len is 5. And so now we have our while loop. while I is less than len. So 0 is less than 5. Print line, and here we're calling a function on our string variable, and we're calling the char@ function to get a letter in the string. I is 0, so we're calling char@ 0, so that's going to return h, and we're going to print out h. And then we're going to increment I, so I will be 1 because I was 0. We come back up here, we test, is 1 still less than len, which is 5, so 1 is less than 5. We're going to get the character now at 1, which is going to get us the e, so we print out the e, and then we increment our number, and we are at 2. So then we print out the L, etc. So what's important to note in this example has a lot to do with strings and avoiding an off by 1 error. We want to make sure that this is I is less than len, not less than or equal to len, because if we let I be 5 and that was still true, we would be calling my string.char@ 5. And remember, this is indexed from 0. 0, 1, 2, 3, 4. There is no character at 5. So we have to make sure that when we're doing things like this, where we're indexing into a structure that's indexed from 0, we use len, not less than len, not less than or equal to len. Okay, and so if we run this code, you can see that on each line, it prints out each character one at a time. There's the hello printed one character at a time. All right, here's an example with drawing. If we want to write a loop that will draw a series of horizontal lines every 30 pixels down the canvas, we're going to set up our canvas. We again have an initialization code. We're going to set a variable I to 0. This is sort of our counter variable. We're going to set up some drawing stuff, red heavy line, and then we say while I is less than height, because we don't want to keep drawing lines below the bottom of the canvas, and the bottom of the canvas is defined by height. So while that's true, we're going to draw a line from 0i, which is the left side of the canvas, and I pixels down, to width I, which is the right side of the canvas, I pixels down. So this draws a horizontal line. It'll draw the first horizontal line at 0 down, and then we're going to add 30 to I. And so then the next horizontal line will come up. I is 30. 30 is still less than height because our height is 500. We're going to draw a line from 0, 30 to width 30. So it draws another horizontal line, but 30 pixels below. And then we do this again. And so if you execute this, you'll see that we get something that looks like this. We've got a whole bunch of lines drawn down the canvas. And the question to ask here is, how many separate individual line commands would you need if you didn't have this looping structure? And since there's lines every 30 pixels down and we've got a 500 pixel tall canvas, we're talking about 16 or 17 different line commands that we would have to write to get all of these lines to appear on the canvas if we didn't have the loop. And that would look something like this. Line 00 with 0, line 030 with 30, line 060 with 60. You can see, and this only draws just the first part of them. We have to go all the way down to a height of 500. So this structure up here, this while loop that we're using to draw a bunch of lines for us, has a lot of advantages. It saves us a lot of typing, obviously. It keeps the code shorter, and it limits the number of typos you're going to make, because if you have to do many of these, at some point you're probably going to type a number wrong. And so this can eliminate actual error drawing. All right, one last example. Write a while loop that draws 10 dots in random spots on the canvas every frame until the user clicks the mouse to stop it. So here we have user interaction and using Booleans in a while loop, as well as counting. So because we want to draw 10 dots every frame, so we have to count in our loop. And so here's the code that makes that happen. First, we have a Boolean, and it's to keep drawing. So we're going to set that initially to true because we want to keep on drawing dots until the user clicks the mouse, and then we stop it, and then we'll set that to false. We have a setup, of course, and we have a draw. And of course, we want to draw 10 dots every frame. So in each frame, we're going to initialize num dots to 0, and then we're going to have a while loop. While keep drawing is true, and it starts off as true, and our num dots is less than 10, let's draw some random dots. So we pick a random reddish color and we draw a dot in a random place that's fairly small, and then we increment num dots. So this while loop will draw 10 dots as long as keep drawing is true, as long as we haven't clicked the mouse button, and as long as num dots is less than 10. At some point it draws its 10 dots and then it stops, but then this will get called again the next frame. So this is going to keep drawing dots over and over again, 10 more every single frame, so 10 more every 60th of a second, until we actually do something to make the keep drawing false. And that happens when we press the mouse down here. When the mouse gets pressed, keep drawing becomes false, and then this will become false, and we won't be doing this. So this whole expression has to evaluate to true. This is a compound expression. There's this part and this part. And so if keep drawing is false, we won't even bother with this part, because both parts have to be true for the whole thing to be true. And so this will end up giving us something that looks like this. It would draw lots and lots of dots, but at some point you click the button and it stops and you get a static image of a bunch of random dots. Okay, so that's some examples of using while loops in processing and in general. And in the next video, we'll talk about common bugs with while loops.